The universe is a vast and mysterious place, and its future has always been a subject of intense study and speculation. What awaits it at the end? Let's explore some of the most popular and scientifically grounded theories. Hey friends, this is And Hear the Space, and today we're diving into one of the most intriguing and perhaps grandest mysteries: what will happen when the universe reaches its end? This is a topic that has captivated the minds of scientists and philosophers for centuries, and there are several fascinating theories we'll explore today. Buckle up, because we're going on a journey to the very edge of time. The expanding universe. How do we know? Before we talk about the end, let's quickly recap how we even got to these theories. A key discovery of the 20th century was the expansion of the universe. Edwin Hubble found that galaxies are moving away from each other, and the farther away a galaxy is, the faster it's moving. This observation formed the basis of the Big Bang theory, which states that the universe began in an incredibly hot and dense state and has been expanding ever since. Initially, it was thought that this expansion would slow down due to gravity. But in the late 1990s, new observations showed that the universe's expansion isn't slowing down, it's actually accelerating. This led to the concept of dark energy, a mysterious force believed to be responsible for this acceleration. Dark energy makes up about 68% of the universe's total energy and mass, but its nature remains one of the greatest mysteries of modern physics. Understanding how the universe expands is key to understanding its potential end. Different end-of-universe scenarios directly depend on how dark energy and gravity will behave in the distant future. Scenario 1. The Big Crunch. One of the earliest and perhaps most intuitive theories for the end of the universe is the Big Crunch. This scenario suggests that the universe's expansion will eventually slow down, stop, and then reverse. Imagine blowing up a balloon. The Big Crunch would be like the balloon, after reaching its maximum size, starting to deflate on its own. If the gravitational pull of all the stars, galaxies, and dark matter in the universe is strong enough to overcome the momentum of its expansion, then the universe will begin to contract. Galaxies would draw closer, temperatures would rise, and eventually, all matter in the universe would collapse back into something resembling the initial singular state from which it originated. This would be a kind of Big Bang in reverse. However, given the latest data on the universe's accelerating expansion, the Big Crunch scenario is becoming less and less likely. Dark energy seems to dominate, and its repulsive effect is stronger than gravity's pull. So, while this theory is beautiful in its symmetry, it probably won't come to pass. Scenario 2. The Big Freeze, or Heat Death. The Big Freeze, also known as the heat death of the universe, is currently considered the most probable scenario based on our current observations. This scenario assumes that the universe's expansion will continue indefinitely, and it will become increasingly cold and empty. Here's how it would unfold. Star formation will cease. As the universe expands, the density of gas and dust will decrease. This means there won't be enough material to form new stars. Existing stars will burn out, and no new ones will replace them. Era of degeneration. After all stars have died out, only their cooled remnants will remain. White dwarfs, neutron stars, and black holes. These objects will slowly cool and fade. Black hole evaporation. Even black holes aren't eternal. According to Stephen Hawking's hypothesis, black holes emit what's called Hawking radiation and slowly lose mass. Over incredibly long eons, much longer than the current age of the universe, even the most massive black holes will evaporate. Diluted emptiness. Eventually, the universe will consist of extremely sparse gas, photons, and leptons, like electrons and neutrinos. Scattered across vast, almost infinite distances, the temperature will approach absolute zero. Heat death. This state is called heat death because the universe will reach maximum entropy. This means all energy will be uniformly distributed, and there will be no temperature or energy gradients to drive any processes. Nothing will happen. The universe will be dead, cold, and empty. Scenario 3. The Big Rip. The Big Rip is a more extreme and dramatic scenario, also linked to dark energy, but in a more destructive form. If dark energy becomes even more powerful over time, and its density increases rather than remaining constant, it could lead to the ripping apart of everything. In this scenario, dark energy wouldn't just push galaxies apart, but would overcome all other forces in the universe, including gravity, electromagnetic forces, and even the strong and weak nuclear forces, rip of galaxies. First, dark energy would begin to tear galaxies apart, overcoming their gravitational attraction, rip of stars and planets. Then, it would begin to tear apart star systems, pulling planets from their orbits and dispersing stars, rip of atoms. In the very last moment, just before the end, the force of dark energy would become so immense that it would overcome the electromagnetic forces holding atoms together, tearing them into elementary particles. Rip of spacetime itself. Ultimately, a fraction of a second before the end, even spacetime itself would be torn apart, and the entire universe would cease to exist in an instant. This scenario requires dark energy to behave in a specific way, that its density increases over time, which current observations don't yet confirm. However, it remains a fascinating, albeit deeply unsettling, possibility. What about other theories, cyclic models and other ideas? Beyond these three main scenarios, there are other less common but equally interesting ideas. Cyclic models, Big Bounce. Some theories suggest that the universe doesn't just end, but goes through an endless cycle of big bangs and big crunches. In this case, after a big crunch, the universe would explode again, starting a new cycle of existence. This could explain why our universe has certain properties that make it suitable for life. However, such models face significant challenges, such as the accumulation of entropy from cycle to cycle, eternal inflation and the multiverse. The theory of eternal inflation suggests that after the Big Bang, inflation, very rapid expansion, never completely stopped. Instead, our universe is just one bubble in an infinite multitude of other universes that are constantly forming. In this case, there is no end to the multiverse as such. There is only the endless emergence and disappearance of individual universes. Vacuum decay. This is a highly exotic scenario that suggests at some point the fundamental laws of physics could change. Our universe might be in what's called a false vacuum, and if it were to transition to a true vacuum, it could lead to catastrophic changes propagating at the speed of light, destroying everything in its path. It's as if we live in a bubble with stable conditions, but beyond it there could be entirely different conditions incompatible with our existence. Conclusion. So, what awaits the universe at the end? For now, heat death seems to be the most likely scenario, based on our current understanding of dark energy and the universe's expansion. Our universe will most likely expand forever, becoming increasingly cold, dark, and empty. Of course, these theories are based on our current understanding of physics, and new discoveries could always change the picture. Perhaps dark energy will behave differently, or we'll discover entirely new forces and phenomena. Think about it. Our universe is an incredibly complex and dynamic system. Studying its beginning and end isn't just a scientific exercise, it's an attempt to understand our place in the cosmos, our history, and our future. It's a reminder of how small we are, and how grand the universe around us is. What do you think about these scenarios? Which one seems most plausible or terrifying to you? Be sure to share your thoughts in the comments below. Don't forget to like this video if you enjoyed it, and subscribe to the channel so you don't miss new exciting stories about space. See you next time.